All right, let's go back. So we were talking about the domain. Let's introduce the range of a function. So the range of y equals f of x is the set of possible outputs. Okay, so let's go ahead, let's do some examples. Okay, first example, let's take y equals x squared. Okay, this is a typical function. I would almost say it's my favorite function if I had such a thing. Okay, y equals x squared. If you plot points and graph it, which you should be doing soon, you'll find that it looks like this. Okay, the domain, well, there's no restrictions on x. X can be anything. Okay, I'm not doing any division here. I'm not taking any square roots. I'm squaring, but not taking a square root. So the domain, I'm going to write it as all real numbers. I could also write it as negative infinity to x to infinity. Okay, really it's negative infinity to infinity or negative infinity to infinity. All three of those can be used for the domain. The range here. The range here is going to be y goes from 0 to infinity or 0 to infinity. Okay? Keep in mind the difference between the brackets and parentheses. So parentheses, the end value is not included. With a bracket, the end value is included. Okay. Let's do another example. Actually, it's very similar. You're going to almost think it's the same, except for I'm going to change something. I'm going to put a user-made restriction. So this is a restriction that I'm putting on it just because. Okay, so now y equals x squared. X is greater than or equal to 0. So I'm going to start here. Okay, my domain. Well, I've already said it. It's x greater than or equal to 0, which I'm going to write in interval notation. Okay, this is the interval notation. Notice it includes the 0. And the range has not changed. The range is also 0 to infinity. Okay. All right. At this point, I would ask for questions, but I can't answer your questions now because I am separated from you in space and time. Okay. So, but jot down any questions you may have for class. Okay. All right. Let's do another one. Let's take y equals 1 over x. Now, I'm not going to put any restrictions on this. All the restrictions are going to come out from the problem. So, first thing we should look at is the domain. Well, we are not allowed to divide by 0. So that means x cannot equal 0. In interval notation, we're going to write that as negative infinity to 0. We cannot include it. We're going to put this sign to mean we're joining the two sets together. So this sign means a union. Okay. Now let's draw a little graph of this thing. You're going to get used to drawing graphs. At least I hope you do. If I were to draw this, okay, well, 1's on here. When I plug 2 in for x, I'm going to get 1/2. And when I plug 1/2 in for x, I get 2. It's going to look like so on this side. Oop. Okay, and it's going to look like similarly on the right side, or on the left side, but over here. Okay. Now, the range for this function. Well, y is never going to hit the line 0. So it's actually going to have the same range. Y cannot equal 0, or if I want to write that in interval notation, negative infinity to 0 together with 0 to infinity. Now, one thing I want you guys to notice. As we move from left to right, here, this is decreasing, right? It's going down as you move from left to right. But here, well, it's actually also decreasing. Okay, so we're going to say that it has intervals of decrease on negative infinity to 0, and then again from 0 to infinity. Okay, this is intervals of decrease. These are, we keep them separate. We don't have to union them. Okay, let's do another one. Let's take y equals 1 over 3x minus 5. Okay, again, we cannot divide by 0. All right, so we're going to take 3x minus 5 and say that's not allowed to equal 0. Solving for x, 3x is not allowed to equal 5. X is not allowed to equal 5/3. So our domain here, is negative infinity to 5/3, parentheses, meaning that we throw out the 5/3, and then from 5/3 to infinity. All right. Okay, let's just check it to see how much space. Oh, plenty of space. Okay, let's do another one. Let's take y equals the square root of x. Remember, square root, you cannot have a negative under the square root. So our domain is going to be, let me make that a little bigger. Okay, our domain is going to be given by x is greater than or equal to 0, which we write 0 to infinity with a bracket. Again, let's graph this thing. if I graph it, it looks like so. So the range is also, well, it's y greater than or equal to 0, or 0 to infinity. And this one is increasing on, actually, we don't include the endpoints when we talk about increasing or decreasing. So it's increasing on 0 to infinity. Okay. Let's take another one. Let's take y equals the square root of 5 minus 3x. So, remember, our domain. Okay, our domain, well, we need 5 minus 3x to be greater than or equal to 0. 5 to be greater than or equal to 3x. So x is less than or equal to 5/3. So our domain is actually negative infinity to 5/3. Okay, it's a little tricky, but you can see how it changed. So the key point is, don't try to do this in your head. Don't try to be like, oh, x has to be greater than or equal to 0. I've seen lots of students do that. Start with what's underneath the square root and say, you know what? That's what needs to be greater than or equal to 0. And when you do that, it will set you up and give you the proper values for x. Okay? All right? Let's take another one. Let's take y equals 1 over the square root of x. And we're going to find the domain here. Okay. Give me...